Here we're going to take a look at the inverse of each function. So the inverse means that we're looking for the reflection over our x equals y axis. So this dashed line is our x equals y, and right now, if we look at number 1, this is the function 4 minus 3 over 2x. So I'm looking for the reflection over this axis, and to do that, we swap out the x and y. So g of x is the same thing as y, and here's x. So I'm just switching the places. I'm going to make this x equals 4 minus 3 over 2y. Okay, so we're trying to solve for y and get y alone now. I first subtract 4 to the other side. And then now I can just multiply by the reciprocal of negative 3 over 2. So that would be negative 2 over 3. And I multiply by that on both sides. So I have to multiply everything by that negative 2 over 3. This cancels out, and I'm left with negative 2 over 3x. I'm just distributing into here, plus 8 over 3. And that is our inverse. So the notation for inverse is g and then this little negative 1 of x for our answer. So I can check this answer by looking back at Desmos. And this is what we have, negative 2 over 3x plus 8 over 3. And I can see that it does reflect over that x equals y line. So if you have Desmos, you can always check your answers by typing in x equals y and then seeing if this is a reflection over that axis. So it should intersect at the axis there. Okay, so that's what we're finding when we switch out this x and y. Number 2, f of x is the same thing as y, and we're switching the x and y. So I'll do x equals negative 16 plus y over 4. So I'll first multiply by 4 on both sides to get it out of this denominator. And then just add 16 to the other side. So my inverse of this function will be 4x plus 16. And again, you can check that on Desmos. We're going to take a look at number 5 here. So this is the same thing as y, so I'm going to make it x and make it negative 2 over y plus 1. So what I'm going to do here is I'm going to multiply by y plus 1 on both sides. This way I can get rid of the denominator with y in the denominator. So it cancels out over here. And I'm not going to distribute x. I'm going to keep it like this. And now I'm just left with negative 2. So now all I have to do is divide out the x to get it out from that side. So just kind of working on both sides here. I have y plus 1 left over here and negative 2 over x here. All I need to do is subtract 1 to solve for y. So my inverse of this function would be negative 2 over x minus 1. Okay, so there is another way we can do this. So I multiplied by what was in the denominator and then divided out the x. But we can use our negative exponents to do this, and I'll show that with this function. So this is x equals 1 over y minus 2. So solving for y, I'm going to add 2 to the other side. And since y is in the denominator, all I need is for this fraction to flip. So it's just y over 1 or just y. So to get this to flip, I'm going to use my negative exponent rule. So if I raise this to a negative exponent, it will flip the fraction. So if I do that to this side, I have to do this to the other side also. So x plus 2 to the negative 1 power, now this becomes the denominator. And now this flips to be y over 1 or just y. So my final answer here is just 1 over x plus 2. So this is just another option for solving this using your negative exponent rule, and it saves you time from doing back and forth like number 5. Okay, and lastly, I want to look at number 9. So I'll make this x equals 2y to the third. I would first subtract 2. And then I'm trying to get whatever's raised to the exponent alone. So I would divide out this 2 before I do anything. And I'm going to keep it like this, x minus 2 over 2. Now to solve for y, I would take the cubed root. So since I'm taking the cubed root, there's some rationalizing that I need to do here. So taking the cubed root is taking the cubed root of the top and the cubed root of the bottom. So I'm trying to get rid of the radical in the denominator. To do that, I need to multiply by the same radical, and this is the third root, so I'm looking for groups of 3. Right now I have 1, 2, and I just need 2 more 2's. And I do the same thing in the top. Okay, so my final answer here, I would distribute this 4 into here to get the cubed root of 4x minus 8. And the cubed root of 2 to the third is just 2. And that will be your final answer.